Flexible conduits offer a practical solution for underground power feeds, especially when dealing with irregular terrain. These conduits, often made from polyethylene or polyvinyl chloride, commonly known as PVC, are designed to be lightweight and highly flexible, adapting to elevation changes without requiring numerous bends. Two recommended conduit types are flexible non-metallic conduit, known as FMC, and liquid-type flexible metal conduit, called LFMC. Firstly, let's discuss flexible non-metallic conduit, or FMC. This is a lightweight and flexible option known for its resistance to corrosion and sunlight, making it suitable for underground installations. Secondly, there is liquid-type flexible metal conduit, known as LFMC. LFMC consists of a corrugated metal core with a liquid-type PVC coating, providing enhanced protection against moisture and debris, which is crucial for underground applications. Several installation considerations must be taken into account for a safe and compliant installation. 1. Bury depth. The conduit should be buried at a minimum depth of 18 inches below the ground surface to protect it from physical damage and environmental factors. 2. Protection from damage. It is important to protect the conduit from potential damage by either encasing it in concrete or using a protective sleeve. 3. Slope. If the terrain includes elevation changes, ensure the conduit has the slope to allow water to drain properly, preventing water accumulation inside the conduit. 4. Bends. While flexible conduits are designed for easier bending, it is crucial to maintain gradual bends to avoid damaging the enclosed wires. 5. Encasing in cement. Enclosing the conduit in cement is generally not necessary if the conduit is adequately protected. However, if you desire additional strength and protection, you can encase the conduit in a minimum of 2 inches of concrete. Remember that using number 2 copper THWN wires requires both grounding and neutral wires. Ensure these wires are included within the conduit. Always use appropriate fittings and connectors to establish secure and waterproof connections at all junctions, and it's always recommended to contact your local building inspector or a qualified electrician to obtain any necessary permits or approvals before starting the installation. Now let's go into these aspects in more detail. Selecting the right type of flexible conduit is crucial for ensuring the longevity and safety of your underground power feed. FMC, or flexible non-metallic conduit, is a popular choice due to its lightweight nature and ease of installation. It is made from PVC or polyethylene, materials that are inherently resistant to corrosion from soil and moisture. This resistance is essential for underground applications where the conduit is in direct contact with the earth. FMC is also resistant to sunlight, preventing degradation of the material over time, even if portions of the conduit are exposed. However, FMC does not provide the same level of physical protection as metallic conduits. While it can withstand some impact, it is more susceptible to damage from sharp objects or heavy loads. LFMC, or liquid-type flexible metal conduit, offers a higher degree of protection. It consists of a flexible metal core, typically steel or aluminum, covered with a liquid-type PVC coating. This construction provides excellent resistance to physical damage, as well as protection against moisture, oil, and chemicals. The liquid-type coating prevents water from entering the conduit, which is crucial in wet or damp environments. LFMC is more robust than FMC and is suitable for applications where the conduit may be exposed to mechanical stress or potential impacts. When choosing between FMC and LFMC, consider the specific conditions of your installation site. If the conduit is buried deep enough to avoid physical damage and the soil is not particularly corrosive, FMC may be a cost-effective solution. However, if the conduit is likely to be exposed to mechanical stress, moisture, or chemicals, LFMC is the better choice. Proper burial depth is critical for protecting underground conduits from physical damage. The National Electrical Code, or NEC, specifies minimum burial depths for different types of conduits and applications. For residential branch circuits and feeders, the minimum burial depth for rigid metal conduit and intermediate metal conduit is 6 inches. For PVC conduit, electrical non-metallic tubing, or ENT, and reinforced thermosetting resin conduit, or RTRC, the minimum burial depth is 18 inches. These depths are designed to protect the conduit from damage caused by digging, vehicle traffic, and other activities. When burying flexible conduit, it is generally recommended to follow the same burial depth requirements as PVC conduit, which is 18 inches. This depth provides adequate protection against most common types of physical damage. However, if the conduit is located in an area subject to heavy traffic or other potential hazards, it may be necessary to increase the burial depth or provide additional protection. One way to provide additional protection is to encase the conduit in concrete. A concrete encasement provides a strong, rigid barrier that protects the conduit from impact and compression. The minimum thickness of the concrete encasement should be 2 inches on all sides of the conduit. The concrete should be a high-quality mix that is suitable for underground use. Another way to protect the conduit is to use a protective sleeve. A protective sleeve is a rigid or semi-rigid tube that is placed around the conduit to shield it from damage. Sleeves can be made from a variety of materials, including steel, PVC, and polyethylene. The sleeve should be sized to fit snugly around the conduit and should extend beyond the burial depth to provide complete protection. Proper slope is essential for preventing water accumulation inside underground conduits. Water can enter the conduit through condensation leaks or groundwater infiltration. If water accumulates inside the conduit, it can corrode the wires and other electrical components, leading to failures and safety hazards. To prevent water accumulation, the conduit should be installed with a slight slope, typically 1/4 inch per 10 feet. This slope allows water to drain out of the conduit and away from the electrical components. The slope should be continuous and consistent throughout the entire length of the conduit run. If the terrain changes elevation, it may be necessary to install additional drainage points to ensure that water can drain properly. Drainage points can be created by installing junction boxes with drain holes or by using specialized drainage fittings. Flexible conduits are designed to be bent and flex, but it is important to avoid sharp bends that can damage the wires inside. The NEC specifies minimum bending radii for different types of conduits and wire sizes. The bending radius is the radius of the curve formed by the bend. The minimum bending radius is typically expressed as a multiple of the conduit diameter. For example, the NEC specifies a minimum bending radius of 6 times the conduit diameter for PVC conduit. When bending flexible conduit, use a conduit bender to ensure that the bend is smooth and consistent. Avoid kinking or flattening the conduit, as this can damage the wires and reduce the conduit's capacity. If you need to make a sharp bend, use a conduit fitting instead of bending the conduit itself. Enclosing the conduit in cement provides additional protection against physical damage and environmental factors. A concrete encasement can protect the conduit from impact, compression, and corrosion. The minimum thickness of the concrete encasement should be 2 inches on all sides of the conduit. The concrete should be a high-quality mix that is suitable for underground use. Before pouring the concrete, make sure the conduit is properly supported and secured. Use conduit straps or hanners to hold the conduit in place and prevent it from shifting during the pour. After the concrete has been poured, allow it to cure properly before backfilling the trench. Curing time will vary depending on the type of concrete and the weather conditions. Always include both grounding and neutral wires when running power feeds to subpanels. The grounding wire provides a path for fault current to return to the source, helping to protect against electrical shock. The neutral wire provides a return path for current under normal operating conditions. The size of the grounding and neutral wires should be determined based on the size of the circuit and the requirements of the NEC. It is generally recommended to use the same size wire for both the grounding and neutral conductors as the ungrounded conductors. Use appropriate fittings and connectors to ensure secure and waterproof connections at all junctions. Fittings and connectors are used to join sections of conduit together and to connect the conduit to electrical boxes and equipment. It is important to use fittings and connectors that are specifically designed for the type of conduit you are using. For example, if you are using PVC conduit, use PVC fittings and connectors. If you are using LFMC conduit, use LFMC fittings and connectors. Make sure the fittings and connectors are properly tightened to create a watertight seal. Use a pipe wrench or other appropriate tool to tighten the fittings and connectors. Avoid over-tightening, as this can damage the fittings and connectors. Contact your local building inspector or a qualified electrician to obtain any necessary permits or approvals before starting your electrical installation. Electrical work is subject to local codes and regulations, and it is important to obtain the necessary permits and approvals before starting any work. A building inspector can review your plans and inspect your work to ensure that it meets the requirements of the code. A qualified electrician can provide guidance and assistance with your electrical installation, ensuring that it is safe and compliant.